Today we're going to talk about areas of circles and therefore sectors. We're going to talk about circumference of circles and therefore the measurement of arcs. One idea I want you to keep in mind as we go through this is the idea of proportions. All right, so we're going to start by talking about these formulas. Area and circumference. This is where pi comes from, okay? Is that long time ago, way before we had to worry about it, people were calculating the area circles and kept saying this number keeps popping up. That when I take the area of a circle and divide it by r squared, the radius squared, I keep getting this constant value. When I take the circumference of a circle, so you can imagine, right, that you have a circle of rope and you make an incision, and then I guess you wouldn't need to make an incision if it's rope. But anyways, okay, the point I'm trying to make is you unravel the rope, you measure it, and you find out, if I divide that circumference, that length around the circle, by the diameter, we write it as 2r. I think that's just because we use r, we use the radius in area as well. But twice the radius is the diameter. So you find, wow, it looks like if I divide the length of the circumference by the diameter, I keep getting this constant. For our sake, we're just going to keep using pi as 3.14. A lot of your calculators have buttons anyways. But for simplicity's sake, we'll use this as our constant value. So this is where that constant value comes from, and these are our two equations. So the circumference, of the distance around the circle, is 2 pi r. You could think about it as pi times the diameter, or think about, typically you're going to get just the radius as information. So you double the radius, you multiply it by 3.14, you'll get the circumference. You take the radius, you square it, and then you multiply by pi, and that will give you the area, all the space that's inside of the circle. So how does this apply to finding the areas of sectors? Well, like I said, it's all just a proportion. It's all just a proportion. So when we deal with a sector, which we make from a central angle, what you need to worry about is whatever percentage of the circle this takes up. So if it's, a good example is if it's 90 degrees, 90 out of 360 simplifies to 1/4. So that means that sector is 25% of the entire circle's both area and circumference. So you would take that ratio 1/4 and multiply by the total area to get the area of the sector, or multiply by the circumference to get the total measurement of the arc. So it's all just proportions. It's just proportions, right? So to find the area of this sector, whatever the degree is out of 360, or in this case it's the arc, whatever it is out of 360 multiplied by the circumference gets you the length L of that arc. So here we have some great examples. So ready, let's just focus on C right here. Let's just focus on this one right here. All right, what we're going to do is we're going to say, well, I got 120 out of 360. That's 1/3. I'm going to take that 1/3 and I'm going to multiply it by, if I'm looking for the arc length, then I just need to do circumference. So 2 times the radius of 11 times 3.14. And so whatever that total is, that's my total circumference. And then I'll take 1/3 of it to get my answer. All right? It's a very repeatable process. The best thing you can do is jump right in to practice. So there's some practice problems right here to try. Right? Remember, your goal is, okay, here they're asking me to find the circumference. This is kind of a tricky one, so I want to talk about it. Meaning they want the total. They want the total, and they're telling you that this arc right here is 61.26. So what they want you to do is do 270 over 360. If I divide both of these by 30, get 9 over 12. Oh, hey, wait a second. That's 3/4. So you're telling me that's 3/4? So what you would do is 61.26 over the total circumference equals 3/4 of the whole thing. So you'll cross multiply. So you'll have to multiply this by 4 and then divide it by 3. Right? So that's about as tricky as they can get, is a process like that. All right. So there's lots of practice in here. We're going to do this activity as a group in class. This is a short video, but it's a pretty straightforward process.